We're going to take what we did in the first video for 7.4 dealing with the side splitter theorem and talking about a specific side splitter called the midsegment. The midsegment is, if you think about it, similar to midpoints. It's actually the segment that connects two midpoints. So side splitter theorem takes the midpoint of one side and connects it to the midpoint of the other. What that does is it gives us one side that's 3 and 3, another that's 4 and 4. And what's special about the bases now, we actually can do something with this theorem, is that the small base is half the length of the big base. So B and C are midpoints, meaning BC is a midsegment. If AD is 10, AC is 3, and BC is 4, I need to find the remaining sides. So I want BD, I want AE, and I want DE. So BD, right here, I know that it's congruent to over here because B is a midpoint, so half of 10 is 5. AE is this entire segment. Well, that's twice this because those are congruent as well. And DE is 2 times as big as the midsegment. Same picture, same given that they're both midpoints. What we're going to do is start to solve. BC is 2x plus 5, and DE is 6x. I need to find x, then I need to find DE, so I will have to plug it back in. And to find x, I know that BC is half of DE, or that DE is twice as big as the midsegment. So when I start to solve this, I get 6x equals 4x plus 10, 2x equals 10, so x is 5. So there's part of my answer. And I'm going to take 5, and now I'm going to plug it back in. And DE is 30. So, example 3, the 3 midsegments are the 3 that are in the middle. UV is a midsegment, UW, and VW. And if RS is 8, RU is 3, and TW is 5, find the lengths of all the midsegments. So, since RT is 3, I know that this entire side is 6, and that this is 3. Since TW is 5, I know this entire side is 10, and this is 5. And these are both 4 because it's a midpoint. So, half of 8 is 4, half of 10 is 5, half of 6 is 3. So we have 2 other questions that we have to answer. What's the perimeter of the big triangle, and what's the perimeter of the triangle comprised of just the midsegments? 6 plus 8 plus 10 is 24, and 3 plus 4 plus 5 is 12. Now one thing to keep to notice, look at these 2 perimeters. They're half of each other. The midsegment perimeter is half of the original triangle's perimeter. And the reason is each of these are a midsegment, which is half of one of these sides. So we're going to work through 6 problems to hopefully get a better understanding of what's going on up to this point. So the height of 2 vertical posts are 2 meters and 0.45 meters. And the shorter post has a shadow of 0.85 meters. What is the length of the longer shadow? We're going to set up a proportion 2 over x equals 0.45 over 0.85. Keep in mind how I have them aligned. I have height over shadow and height over shadow. When we cross multiply, 0.85 times 2 is 1.7. So we have 1.7 equals 0.45x. And I'm going to divide by 0.45, and I get that x is 3.77 repeating feet. Okay, we have 2 lines that are parallel, which means that MN is following side splitter theorem. So I can take these two and set them into proportion, and then I can take these two and set them into proportion. So 12 over 18 is 16 over 3x. I took the small over the big, small over the big. When you cross multiply, 18 times 16 gets you 288, and that's equal to 36x. Divide, get x is 8. Now in this next one, B and C are midpoints, which means that BC is a midsegment. AD, the entire segment here, is 12. AE, the entire segment, is 14. And DE is 16. So I need to find BD, I need to find AC, and I need to find BC. Well, BD is half of 12, because both of these are 6. AC is half of 14, both of these are 7. And BC is half of 16, which is 8. This is the side splitter theorem corollary, that three parallel lines follows the same rule as midsegment. So 2x minus 2 over 13.5 is equal to 8 over 18. We're going to cross multiply 18 times 2x minus 2, and 8 times 13.5 is 108. We're going to distribute 36x minus 36 equals 108. 36x equals 144, and we get x is 4. Now it doesn't ask, but I could plug that back in, 2 times 4 minus 2, and get that this segment over here is 6. Problem number 5, determine if they're similar. If so, justify and find RT. Triangles are similar because these two angles are congruent and these two angles are vertical. So it's similar by AA similarity. And then because they're similar, I can set up a proportion. Notice how 6 is connected to the two congruent angles, as is 15. So 6 and 15 go together. And then 2x minus 4 and x go together. When I cross multiply, 15 times 2x minus 4 equals 6x. 30x minus 60 equals 6x. Negative 60. Most common, we always forget that negative sign. Remember to bring that down. When I subtract 30, I got negative 24x. And then 60 divided by 24, negative 60 divided by negative 24, gets me that x is 2.5. Question says find RT, so I'm going to take RT. I'm going to plug it back in, 2x minus 4, so 2 times 2.5 minus 4, that's 5 minus 4, or 1. And the last problem on this video, D, E, and F are all midpoints, which makes all three of these midsegments. So I'm going to mark this picture that those are all being split. DE is 10, EF is 15, and FD is 17. I need to find the perimeter of the big triangle. Now, because they're midsegments, that means that 10 is half of this side. The side EF that's 15 is half of this side. And the side FD, which is 17, is half of this side. I'm going to add all those up, 20 plus 30 plus 34, to get that the perimeter of the big triangle is 84. An alternate way to do that is, let me rewrite these in red. Let me erase them. An alternate way, let's do it the whole thing in red. This one's 10, this one's 15, this one is 17. 10 plus 15 plus 17 is 42. So the perimeter of the small triangle is 42. I'm going to multiply that by 2 and get 84 as well.